Hello everyone, welcome to Vetur. I'm Rahul Kadyan, and today I'm going to talk about the state of developer experience while using Vue with or without TypeScript. Let's start with my personal journey. My first programming language was C++, so I learned programming with the concept of types. Then I moved on to PHP, basically using Laravel. By then, PHP had a type system, but mostly types were optional, and I loved skipping types. It was something like a cheat built into the programming language where you can skip some types. And eventually I landed into a situation where I needed to do some front end stuff and was introduced to JavaScript. This whole language is a cheat. There are no types, there are no static types. Obviously, there are types at runtime. So I loved a typeless system where any variable can be anything. You can assign a boolean, then you can reassign that variable with an integer, maybe a string, an object, a function. You can go crazy. For a while, I loved it, but as my applications started getting bigger and bigger, it became a problem. It was hard to know what would work and what would break at runtime. So I started to look for a type system. TypeScript was quite a jump, and I was enjoying my freedom of not specifying types. I wanted something middle way. And I found that some IDs, particularly VS Code, supported uh, JSDoc. It's a semi type system sort of. Like you can add comments and you can define types there. And VS Code using TypeScript language server would try to infer types and give you a better developer experience. And you can actually run TypeScript to check your types. It was amazing. So I explored it, went through all the details, and tried to figure out how we can utilize this thing in Vue. So in November of 2018, I wrote this article, how you can use TypeScript without using TypeScript. So it was all about how you can utilize JSDoc to add type annotations enough to check your type check some parts of your code and get relevant intelligence from the ID. I went ahead and write one more how you can use UX without TypeScript. And Vuex is notorious to support types. It uses strings as mutations, so it required a lot of work if you wanted to support types using JSDoc. You can go through this article. Here's the link. But eventually, I ended using TypeScript, and I I love TypeScript now. So that's my journey. Let's see the journey of Vue and TypeScript. Vue 1 was written in pure JavaScript, and when it grew out of its original goals, we had to rewrite it. And I guess back then, Flow was a more robust type system, and I think that's why the team chose it over TypeScript, and it served its purpose well. But towards the end, when we were looking at another major rewrite, TypeScript has already grown a lot in popularity, in robustness, and overall support, type support of the language. So this time we took TypeScript, which has improved uh, in many ways. Like maintenance burden has reduced a lot. It's easy to navigate through Vue's source code, and like we don't have to maintain TypeScript types now because they are automatically generated from the source. And end users also get lots of benefit because all the IDs use these type definitions provided by Vue to provide intelligence when you are working on Vue projects. So Vue has an interesting API, the options API, and it's quite difficult to support this kind of API in TypeScript. The main problem arises from having these multiple properties on this options object which share same context. That this object is sort of a amalgamation of all the properties we provide here. So like we are defining this message in data, but we can access it inside a method using this dot message. And to type this object, it's quite cumbersome. And it was very difficult when we were working on Vue 2, but both Vue and TypeScript have grown a lot, and there are many features which make this thing possible today. In Vue 3, we are shipping a no operation, like a transparent function defined component, which doesn't do much, but provides type support, provides types for this object so that this and like can be automatically inferred, and it can work in .vue files, in ts files, in js files. Basically you can take this snippet and put it in any file, in js file or ts file or a vue file. You will get same experience because the define component method sets the this context of the object, the options object. Another improvement Vue 3 did is provide an alternate API, which is not the primary API, but it mainly focuses on functions. And functions are much easier to type compared to an object. So this ref function already defines what kind of argument it accepts and what kind of argument values it returns. So we don't need to type this message because it's automatically picking type from first argument, that's a string. So message is a string ref. And similarly, like methods are much easier to type compared to this context of the options API. But Vue supports both, and they both provide a great experience when you are writing in TS files and also in Vue file if you are using Vetur. So let's go to Vetur. Vetur is a VS Code extension which has become a synonym of developer experience when writing Vue in VS Code. This includes dozens of features including IntelliSense, auto-completion, go-to definition, and so on. And it has an interesting design. Let's look under the hood how it works. Vetur is a two-part system. There is the VS Code extension which runs in VS Code, and there's a language server which runs as a separate process. So when you open some Vue files in VS Code, it will ask Vetur to provide information like auto-completion information or definition information or jump to locations and all those things what you get in VS Code. So Vetur will then ask Vue language server to provide this information. And since a Vue file is a collection of blocks, we have template block, script block, and style block. So this Vue language server internally spawns a CSS language server, a TypeScript language server, and a template language server. And then it shares corresponding code from Vue file to these language servers and collects all the information from them, collates it, and sends back to Vetur. But if we look closer, Vue language server starts a CSS language server, and the CSS extension built in VS Code already starts the CSS language server. So there are two instances of CSS language server running when we are using Vetur. Same happens with TS server. Vetur starts its own TypeScript language server, and TypeScript extension built in VS Code also starts a TypeScript language server. We don't face any problem when we have two instances of CSS language server, because a Vue file is treated as a JavaScript or TypeScript module. So you cannot import a Vue file in a CSS file, or you cannot import a Vue file in style block of another Vue file. That means every Vue file has a separate CSS scope. But in case of TypeScript, we can import Vue files in TypeScript or JavaScript files. And both these instances of TS language server inside Vue language server and VS Code has a different view of uh, how your project looks like. So in the TypeScript language server running in VS Code doesn't understand what is a .vue file, while while the TypeScript language server running in Vue language server understands what is a .vue file. So this results in the problem when you import a Vue file in TypeScript file, you get error. So we have circumvented those errors by declaring star.vue as a TypeScript module. But when we do that, we lose all the functionality of TypeScript. Now we can no longer click on a .vue file and go to its definition. Now we cannot rename that file and get reflected in wherever we have imported those. So that's the trade-off being made there. And let's go back to how Vue language server distributes a Vue file into smaller block into the blocks and gives it to language server. It does by looking at language regions. So let's look at what is a language region. So this is a sample Vue file. Most Vue files look like this. There is a script block and there is a template block, and we have one or more style blocks, zero or more style blocks. We can see this file is amalgamation of multiple files. We have a JavaScript file which includes a script part. Then we have an HTML-like file which includes a template and CSS. And these are language regions. This is a JavaScript language region which is given to TypeScript or JavaScript language server via Vue language server. Similarly, this is handled by template language server built in Vetur, and this goes to the CSS or Sass or whatever language you are using for style to its language server. So in fact, we have three files. So when working on TS plugin, I implemented a virtual file system which represents one Vue file into a collection of these internal temporary files. I call it a Vue virtual file system. So let's say we have this sample file hello.vue. We'll explode it into multiple subfiles. The script file becomes, I'm using 4 underscore as a separator, becomes hello world underscore script.js. This file doesn't exist on file system but lives in memory. Similarly, we have for template and styles. This single Vue file is now represented by these three files in memory, and we are going to use this when we're building the TS plugin for Vue. Let's look at TS plugin. So we have a Vue file and its internal files. TS plugin works with TS, so it understands either TypeScript or JavaScript. So the .vue file, the Vue HTML file, and CSS file are not useful for us. We have this on the script file, but we want IntelliSense and all the TypeScript functionality in template block also. So we will convert the template into a render function, we'll go through this thing, how it converts this thing, converts template into a render function, and then we'll convert a Vue file into a module file, which basically combines script and render function into one. Now, all these files are either TypeScript or JavaScript, and TypeScript language server would understand these. So, how TypeScript extension works in VS Code is it whenever VS Code sees a TypeScript or JavaScript file, it asks the TypeScript language features extension to provide information. Similarly, how Vetur works for Vue files, and then it sends a request to TypeScript language server that have internally a TypeScript language service which does all the processing and returns the result, and it sends the response to TypeScript language server. But TypeScript language server supports plugins, and we are going to write one for Vue. Now let's look at this thing. So first thing we need is to tell VS Code that a Vue file is actually a TypeScript file or a JavaScript file. We do that by configuring TypeScript language server to handle .vue files along with TS, JS, and TSX and JSX files. So now whenever VS Code sees a TypeScript, JavaScript, or Vue file, it will ask the TypeScript language features extension to get information like auto completion and all. So this TypeScript language features extension will ask TypeScript language server, which have our new TypeScript plugin. It acts as an interceptor. So whenever a request comes in, it goes to plugin first. And now depending upon if it's a TS or JavaScript file, the plugin will forward it to the TypeScript language service. If it's a Vue file, it will forward to Vue language service. Now, depending upon where the request has generated, like you're looking for auto completion in script block, then this will take the script virtual file and pass it to the TypeScript language service. So basically in the end, for script block, TypeScript language service is doing all the computation, all the analysis, and giving back whatever information asked by the extension. Now, if it originated in template, the template language service, which will convert this template into a render function and represent in a virtual file and give this virtual file to this TypeScript language server. When all the process is done, we'll get response from this TypeScript language server, and it will come back again to TypeScript plugin. Here we will process this response and we'll look at references to these virtual files and write them back to the Vue files. Now when the response is seen by this extension in VS Code, they see Vue file instead of these intermediate virtual file representations. And in a nutshell, that's how TypeScript plugin works. So script block goes through the Vue language service to TypeScript directly. Template block goes to template language server, converts to render, and TypeScript language service. That's it. Now let's compare Vetur and TS plugin implementations. Vetur looks only at Vue files, and that's the only limitation of Vetur, that it cannot provide intelligence information in JavaScript and JavaScript files, because it works like at the downstream, it just handles only Vue files, whereas TS plugin works inside the language server. So it gets all the TypeScript JavaScript files from VS Code and selectively processes whether it's a TS file or Vue file. Now now we have only one instance of TypeScript language server running, so there is only one knowledge set which has been built by this language server or language service. So if we resolve a Vue file in this TypeScript language server, whether you are importing it in a Vue file, TypeScript file, or JavaScript file, it has been resolved for all of them. So all the features which work in TypeScript and JavaScript file will work in .vue file. But we are doing some heavy lifting here in template language process and language service, and this requires to support all the kinds of requests which you can get here through this TypeScript language server, and that's a huge task. And like most of my efforts are going into that now. So this has been how developer experience is powered in VS Code or any IDE supporting language servers. Another part of puzzle is actually running these type checks inside CI/CD pipelines, and both Vetur and TS plugin have tools for that. So VTI stands for Vetur Terminal Interface, is built upon Vue language server. Type check is built upon TypeScript language server with the TS plugin. If we see the Vetur's internal working diagram again, VTI replaces the extension and VS Code part of it. And similarly, type check again replaces the extensions and VS Code parts of it. So uh, in this case, like VTI and type check can potentially provide same experience, let's say, because when we are writing extensions, VS Code controls what kind of files each extension can see. But in terminal, we can send all kind of files, and potentially both the solutions can be at par now. Finally, let's look at Vue DX. So Vue DX or Vue Developer Experience is a collection of tools I've been working on. It includes TypeScript plugin, and it aims to support Vetur also. But other than that, it has a couple of other things, and we'll see this in a quick demo. So here we have a sample Vue application. See the package.json, I have Vue and compiler as dependencies. Then I'm defining source directory in tsconfig. So how does the main look like? So we see this main, it imports .vue file and it resolves to app.vue. Now if you command click on this thing, this will take you to the definition. And what if I rename this from here? See, file name actually gets updated. And if I rename the file, it will update the imports. This works between Vue and TypeScript files. You can hover over a component and it will show its import statement. If you command click on this thing, it will take you its declaration. If same thing works for props, if you hover, it will say display its type, and if you press command, it will show the type declarations of the prop, and you can click to go to that the declaration part in the file. This works same as how it works in TypeScript, because when we are just enabling the TypeScript language server to understand what a Vue file is. You get error messages like it should be a number, but we are passing a string. You can see its definition, and you can go to the definition. It's a number less. Now, I talked about virtual file system. There is command which shows virtual file built here. So the script is as it is passed as a virtual file. Same happens with style. So style is again passed as it is, and if you say like it's padded, so like line numbers remain same. So uh the so TS plugin has to do TS plugin or anything has to do less work now, because position of this text is same as in the virtual file as in Vue file. And then there is a template to TSX compiler. So if you see virtual file for template, it doesn't show the template as a virtual file. It shows the render function which is generated from this template file. And this render function uses another tool, analyze. We'll see in a bit, to see to understand what are the components you are where are the components you are importing from, and generates this thing. This is TSX, and this context is like this context of this component. If you see, let's say hello world and its template, see it uses destructuring. So template remains pretty much same, how we are writing here, like the render function remains pretty much same how we are writing the template. And like you get this type definition, and TS plugin don't have to do much work because it is very close to how the template looks, though it does some work it does some extra work like converting directories into attributes so we can type check them. And that's pretty much it. Now it's the job of the TypeScript plugin to basically convert this template into render function, pass it to the TypeScript language service, get information from that, remap it to the Vue file, and get the highlights and information in correct positions. So this has been just some of the features I have implemented. Many more are yet to come. Let's look at other tools which I've been talking about. So Analyze. Analyze is a library and a CLI tool also. So you can type Analyze in your Vue project. It will look through all the Vue files and provide some static information. Like in app.vue, I'm using two component, your button, which is imported from component button. Basically it looks at the source codes and convert into this JSON object, and TS plugin uses this object to statically understand where are the definitions of components, props and all, and navigate between them. This can potentially be used for writing, generating documents or like this prop tables out of your source code. And we'll see in a bit, I have another tool in works which utilizes this thing to um, improve the developer experience of writing your applications. Next is type check. So type check is CLI version of same TS plugin. It basically spawns up a TS server, looks through all the errors in the project and prints them. You can get this output as JSON also, so you can represent it however you want. So like the same error we were getting in IDE is also present here. Another interesting thing, so Vue now ships with types for all native elements like button, and since we have defined the type prop to be string, whereas Vue defines the type attribute on button as these three constant strings, so we are getting error for those also. So it will help us, basically it will help us to write HTML also now. Finally, the third tool, I call it preview. So it's a quick prototyping and sort of a component management tool which you can spawn up. So if you're using Vite, it reuses Vite's configuration and spins up a sort of a development server which has list of all the components. And what it tries to do is, if you have, let's say, slots and all, it tries to fill them with dummy values, because It's using analyze to detect like what are the props and all, and it tries to fill those with dummy values so that you get some sort of representation, some sort of preview out of each component without actually defining, for lack of better word, stories for your components. And it uses Pete's watcher, so you can pretty much control this thing hands-free. Let's say you are working here, let's say in hello world.app, and it's showing hello world. You want to switch to button and hit command S. So that would trigger watcher that file has changed, and it will automatically preview will automatically switch to that. You can type here and say it immediately is reflected in this thing. Basically, it's built upon Vite. It uses same configuration and provides a view where you can see your components individually and use it as a prototyping tool. Yeah, that is all what I've been working with, and is coming soon. I say I'm targeting first alpha release by the end of November. So let's see where it gets. So this was Vue with or without TypeScript. So if you see, all the code we have written in this demo is actually written in JavaScript, but we are getting all the benefits of TypeScript. We are getting type check, we are getting IntelliSense, we are getting uh, all the features you get in TypeScript, like go to definition, hover to see types, everything. This has been possible because Vue 3 provides a wide range of types, which helps infer most of the type information from options API or composition API. And TS plugin helps the TypeScript language server to understand what what is there in a Vue file, and that is going to give us amazing developer experience writing Vue. As all, you can find me on Twitter, JarenCK0. I am regularly posting all the updates of Vue DX and TS plugin. I am currently working as software engineer on a super secret project at Grammarly, and I am part of Vue.js core team. I focus on compiler, rollup plugin, some toolings around compiler, and any opportunity to work on exploratory or experimental projects like uh, Vue 3's compiler or TS plugin, which I'm working now. You can find me on GitHub, JarenCK, and I have sponsors now, so you can sponsor me if you want. One last thing, there I have a side hustle. So this thing is called These Metrics. It's a simple privacy focused analytics system. Check out thesemetrics.xyz. That's all for today. Thank you.